Okay, great. Thanks, Amara. Hey, everyone. My name is Dave Nielsen. This is my first time doing this series, and I'm happy to participate. And in particular, I wanted to do this session because it's really my first time getting my hands dirty with Jupyter Notebooks and actually with scikit-learn and some of the other libraries that we'll be talking about today. And this is really something that we as a team are starting to investigate further, and we'll be using Jupyter Notebooks along with other data sets, and we'll be exploring other libraries and frameworks. So this will be my first time, and I'll share some of my thoughts with you about my experience getting started, and particularly around just getting started with data science, because I'm much more of a developer coming into this, as I've always been involved with data around databases, and previously my job was at a company called Redis Labs, where I was focused heavily on Redis. But data science is, of course, a different skill set, a lot of different libraries, a lot of different tools and techniques, and it's quite a lot to learn. So I will share with you some of my thoughts along the way. So I've got two exercises that I'm going to go through, but first what we're going to do is we're going to go over a review of Jupyter Notebook, and I'll show you some of my own experiences getting started, share with you some of my experiences getting started with Jupyter Notebook, and then we'll go into two different exercises. So first of all, you hopefully had attended the previous Jupyter Notebook session where Carmen gave an introduction to working with Jupyter Notebook, and that was specifically intended to help you familiarize yourselves with the environment and to understand the different types of content and just navigation and all the kind of things that you need in order to feel comfortable just getting started. And so if you haven't viewed that webinar, I would go back to the previous session. I think it's up on the community.trustedanalytics.org website. You click on, I think it's videos, and you'll be able to see the previous webinar there, and Carmen did a very nice job. What I'd like to do is just show you more straightforward getting started with Jupyter Notebooks, and then we'll talk about what do you need to do to get your data working within Jupyter, and then preparing it for building your model and training your model. We're not going to get into the actual data science today. That's a lot more than we can cover. I can't cover all of the data and doing the data science, machine learning, etc. in one session. So we're just going to focus on getting your data in there and understanding what it means to get your data into Jupyter Notebooks and prepare it for your work. Okay, so first, the what and how of Jupyter Notebooks. As I said before, check out Carmen's Getting Started with Jupyter Notebooks in Python session. That was on November 29th. And for those of you who just want the shortcut version, what is Jupyter Notebook? Well, it's got this IPython interpreter, which is able to run on a server or on your own laptop, and then you've got this browser-based notebook system which lets you edit your scripts, and you can share these through the web server so that lots of folks can have access to them, rather than having everything on your laptop where you might use R or in some of those other data science tools, but it's mostly stuck on your laptop, so sharing is difficult. And I think that's part of the reason why in the research areas and academia you're seeing Jupyter Notebooks quite popular, because they like to share a lot. So if you don't already have Jupyter running or installed somewhere, you've got a couple different options. You can go to try.jupyter.org, and you can try it there. And I've had some success with that environment, although I did have some trouble. I think maybe it depends on if it has the libraries that you need, and Maybe I just didn't understand how to add the libraries I needed. But the other way to do it, and the way I'm going to do it today, is you can download the Anaconda distribution of IPython, or of Python, and it comes with Jupyter Notebooks. And you get that from Continuum. That's the name of the company, and they have the Anaconda distribution. So that's what I did. I downloaded it. They have multiple versions. I downloaded the version for Windows, which is what I'm using today. And so once you download it and install it, and it's a pretty straightforward installation process, so I don't think you'll have too much trouble there. But once you've downloaded it, then, oops, we're missing some text here, but what you're going to do is navigate to where you've downloaded the blank, which is the tutorials that I'm making available to you, or just any folder where you want to start beginning to create your Jupyter Notebooks. And so you're going to do that in the command line. I think you'll be able to see my screen here, so let me switch over to the command line. Oops, I think I have it still running. Let me break here. Okay, so for in this case, you can see that I have this GitHub folder, and if I do just a quick directory, you can see I've got some different folders in here that I've been working with. And if I cd into my Jupyter Notebooks 102 folder and take a look in there, you can see I've got a couple of tutorials that I've created, and I've actually uploaded these up onto my GitHub page, which if you'd like to download those directly from there, you can. And that is at, I should have listed it here, but I'll just type it in here real quick. I don't know if you can see this, but it's http github.com/dnielsen/ and then Jupyter Notebooks 102. So that's the URL. And by the way, let me see if I can increase the size of the font here. Let's see here, font. Oh gosh, okay. Well, let's just leave that, I guess. Okay. Anyway, so you can download it from github.com/dnielsen, DNIELSEN/Jupyter-Notebooks-102. All right, that's not going to actually run from there. And then once you've navigated into, once you've installed the Anaconda and you've navigated into the folder where you want to work with your Jupyter Notebooks, then you type Jupyter Notebook and hit enter, and this is going to go ahead and launch Jupyter, the IPython notebooks running now as a service on your laptop, and then it will launch a, and it has with it a server, so you have like a web server running on your laptop now, and you can see that it's at localhost 8888, and it is now serving up the files from that directory that you started from, as if it was a web server, but instead of an Apache server or anything like that, you've got the IPython technology, and it's now serving up and computing these pages. So, for example, I can, and you get this dashboard here, which is the typical Jupyter Notebook interface, and I can click on this particular notebook, and it will open up, and I can work with it here. So I'll be coming back to this in a little bit. Let's go back to my slides. Okay. So we've got through launching Jupyter Notebooks from your drive there, and I'm going to give you a quick overview again. I know that Carmen went through some of this, but I just want to make sure we're all up on the same page here. Quick anatomy of the notebook. You basically have three different types of cells. You've got your markdown, you've got your code, and you can also plot out data. So if you take a look at here, you've got a cell that's got markdown, and then this is another cell that's got markdown, and here you've got some a cell that's got some code. Most of your page might be code, as mine is. If I do this workshop a few more times, I'll probably add some more text and descriptions right here in line here, so I'll have more markdown. But that's really up to you. And your cells themselves exist in two modes. You've got your edit mode and you've got your command mode. Right now I'm in the edit mode, and you can see here that, I'm sorry, command mode, which is blue. And if I hit enter though, I can go into edit mode and I can start editing if I'd like. And then I can go back to, here we go. I can run that, and I'm back into command mode. Okay. All right, and then one last introduction to the notebooks before we get going here, and that is you want to run your code. You've got some simple options. You can do Control-Enter, which is the quick and easy way to do it from your keyboard, and you'll know that code has not run if the in brackets is empty. You'll know that code is running if you've got a asterisk, and you'll know that your code has run if you have a 1, a 2, or 3, or any other number in there. And one thing that I learned that was kind of clever is you can actually execute your code in any order you want. So even though you might have your code on a page, you can skip sections and just go to one that you want to run, and you can run it, and you can run it in any order. You can also run your cells by clicking on cells and then run cells, run all, whatever is selected, run below. So it gives you all these different options. Okay. Or you can just click, oops, there you go. You can click this little run button right here, and that'll do it too. And so when you're all done, you can click File, Close, and Halt. So that's right here, File, Close, and Halt. That will save everything, shut it all down. It'll shut down that particular notebook, but you'll still have IPython running in the background. And then finally, when you're all done, you can go back to the command line, and you can hit Control-C. Let's go ahead and do that for you. You can see how it shuts the whole thing down. And now it's not running at all. Of course, you still have these pages up here, but they're now not connected anymore. So you should probably shut those down first. So that's the whole full cycle of how you get going with Jupyter Notebooks. I'm going to go ahead and kick that back in, kick that back up and running so that we can get back to our workshop here. All right. Cool. All right, so that's how you can get quickly going. Now, what I wanted to do in this particular webinar is I wanted to talk mostly about loading your text. Actually, I'm not going to only do it in Pandas. I'm going to do it a couple different ways. And I'm doing really the bare minimum here. I've been watching a few different videos, and I've read the scikit-learn website. So there's a lot there, by the way, at scikit-learn.org. What a great resource. Just tremendous resource, actually, for learning how to get going with data science and machine learning and predictive analytics and all that kind of stuff. Lots and lots of valuable code and descriptions there. And then also I wanted to talk in this project or in this particular webinar about vectorizing your data set, because this is something that I didn't really know about. It was it's probably the most important concept I've learned so far about getting your data ready and understanding how and what your data needs to do in order to get it ready to run in, let's say, some sort of classification process. And so I'm going to talk a little bit about that today as well. So when you watch the videos online, or if you watch or attend a workshop, oftentimes you will learn about the IRIS data set. It's a popular example. I think one of the reasons why it's so popular is it's fairly easy to understand. It is built into a lot of the Jupyter Notebook distributions out there, well, at least the Anaconda one. So you don't even have to install it. It's already set up and running. And I've seen multiple people giving this example. So if you want to watch a more in-depth webinar on getting started with Jupyter Notebooks or data science, do a search for scikit-learn and the iris data set, or scikit-learn and classification, something like that, and you should find some other examples that may go into a lot more detail than I'm going to go into here. But in this particular case, if you're trying to learn how to do some sort of data science, classification is a very good way to start because it's something that we can understand. It's somewhat manual in that you're going to start off with a data set. In this case, you're starting off with a data set that is a measuring of the iris flower. You're measuring the sepal length and the sepal width and the petal length and the petal width. And then there's different classes of iris. There's the setosa, there's the versicolor, and there's the virginica types of irises. And using the sepal length and width and the petal length and width, you can predict which class the particular measurements of a flower will put that flower in. And so that's what we're going to do in this particular project. So you're just simply trying to classify based on measurements what class of iris you have. So it's pretty straightforward. The data set was collected, and it's been, I guess they've cleared up the rights to it a long time ago, so it's free and easy to use. You don't have to worry about getting permission and all that kind of stuff. It's all free and easy. So that's what we're going to do, and I think why don't I go ahead and get started with it first? Well, actually here. We're going to use the scikit-learn library, and it's a great set of, it's actually kind of like a framework, I guess, and then there's lots of libraries and models inside and functions, and it's really powerful. I highly recommend if you're getting started to start with scikit-learn. And you can do data mining, you can do data analysis, you can do machine learning. There's even kind of some deep learning type capabilities in there. But it's a good standard, and it's built on top of other libraries such as NumPy or SciPy and Matplotlib. It's open source, BSD license. And in this particular case, we're going to focus on the classification use case, which is, again, there are many. And with classification, what you're trying to do is identify which category something belongs to. In this case, again, we're talking about categories of iris and a specific iris, trying to predict what category it belongs to. But you can use classification for many other types of applications, such as like detecting spam or image recognition, trying to identify what's inside of an image, and then identifying categories. And there's lots of different algorithms you can use. You can use the SVM, you can use nearest neighbors, you can use random forest. But go check out scikit-learn.org. That's scikit-learn.org, and it's great. Also, we're going to be using I wanted to share with you that scikit-learn works on lots of different numeric data stored as NumPy arrays or SciPy sparse matrices, and sometimes, though, you need to convert your data, and you might want to use the pandas data frame as well. We'll use that a little bit in this workshop, or this tutorial. And then finally, when you're using your features, sometimes you need to convert them, and so we're going to use pandas for that as well. All right, so let's get back to the workshop. All right, let me just go ahead and pop this open again, the first tutorial or exercise. And again, what we're going to do is we've got this data set that's built in. It comes with Jupyter Notebooks with this distribution, and that makes it really convenient. And we're going to use a scikit-learn to import a data set from, and here's the actual name of that data set that's already available in this Jupyter Notebook distribution. And so I'm going to use the load well, first of all, I'm going to import, and then I'm going to set the iris variable equal to load iris, and it's going to default as a NumPy array. So let's go ahead and run that. Again, I can hit Control Enter, or in this case, just make it visual for you. I'll click on the Run button. You can see it turned to an asterisk and then turned to a 1. That means that it's completed. Now, in this particular case, it's loaded that data into this iris variable, but there's nothing visual about that, so you didn't see any output. So, but to be able to see some output, what we're going to do now is we're going to print the iris data shape. Okay, and you might ask, well, what's a shape? A shape is basically telling you, is this, you know, a multi-dimensional array? Is it just a simple one value? You know, what do you have? And then we're also going to print the target data shape. So, like, what shape will our target a response vector take? And that can be labels, that can be outputs. Those are basically the values that tell us what category the iris is. Let's go ahead and run this. Now we can see that we've got the shape is 150 by 4. So basically we have 150 measurements, or I'm sorry, rows with 4 measurements each. And if you can recall, that's the sepal length and width, and it's the petal length and width. That's the 4 values. And then this is the target, basically the categories, and it's telling us that there's going to be 150 of them. And for some reason, that's just a single value. It's not an array of any sort. Okay. So we got our 150 records, and we're going to now, in this particular case, what we're going to do is we're going to load them into a Pandas data frame. And this gives us a little bit more flexibility. So we can actually give it, for example, we can give it name, like the headers can have names. And so when I run this one, I'm going to load, well, first of all, I'm going to import the Pandas class, and then I'm going to load up the iris data into that. So iris data is the actual 150 rows. I'm also going to specify that the names also be added as column heads. And then I'm going to output just the top 5 rows so we can see an example of what we've got. So let's go ahead and run this. Okay, it's running. And you can see the output here. And you can see what we've done is we've created a data frame, and the data frame has a little bit more value to it. It has the column headers, and it gives you a row index here. And you can actually see the values. Okay, now you can see the sepal length and width, the petal length and width. Okay, but you can't actually see what the classifications are. Right, that's a separate data set. So let's take a look at that. Oh, actually, did I forget something here? Let me just double check. Oh yeah, I wanted to summarize. I wanted to help guide you that we talked about columns and rows. We talked about the iris data and the iris target. Okay. Well, the rows, these individual rows, are also known as predictors or inputs or attributes. So you'll hear them referred to in various ways, but you can refer to it sometimes depending on the type of data or that type of library or framework you're using. You might want to use a slightly better word, a different word, but rows, predictors, inputs, attributes are all kind of the same. I'm sorry, those are the columns. Sorry, my bad. And then the rows themselves are the samples, the instances or records, etc. So, sorry, I had that backwards. So the columns, or that's what I was talking about up here, are the predictors, the inputs, the attributes. And those are like the actual names of those. And then the values would be, or the rows would be the samples or the instances of the records. Okay. Now, as I mentioned, we saw the data which is the measurements, but we didn't actually see what it was predicting or what had been, how each row or set of measurements had been categorized. So let's take a look at that. Okay, here you can see that there are 3 classes represented by 0, 1, and 2. Okay, and this if we go back to my previous slide here, those refer to Setosa, Versicolor, and Virginica. Okay, and you can see here that we've got 150 of them, and some of them are 0s, some of them are 1s, some of them are 2s. So it looks like 0 through 4 would all be categorized as the first category of 0s. And so this is a classification problem. This is not a regression or other type of problem. In other words, we're not trying to plot these on some X and Y axis and create a shape or anything like that. That's not what's happening here. We're just instead trying to predict if the class of a particular data row or set of data or measurements, and so it's going to be a 0, 1, or 2. It's going to fall into one of those buckets. So you got buckets or classes, not some sort of shape that we're trying to create. And with these models, a lot of these models, they require that your data be in a numeric value. Machine learning models do math. They don't really deal with raw text. And maybe there are some out there, but at least these that I'm working with here don't know how to deal with raw text. So you have to convert all of your data into numbers. In this case, the data is already in numbers, so that wasn't hard to do at all. We just needed to load the data up into the data frame and then use these values as our records, or these measurements are basically records that get input into the formula. But if they were text, which in a moment we'll get to one where we do have text, you'll have to turn that text into numbers, which is sort of strange, and that's why I want to. We'll get to that in a moment. That's why I want to. One of the more challenging aspects of this that I ran into. So, okay, so we can see that our rows all have classifications. So they've already been classified, and now what's going to happen is we are going to follow this modeling pattern where we've already imported our data, we've instantiated it, so it's loaded up, and now we're going to fit our data. And basically what fitting does is fit is how you tell your library, what data you have and how it gets to know each other. How do I explain that? Well, let me just back up here for a second. So we're going to use the K-neighbors classifier, and we're going to instantiate that model, and we're just going to use the default parameters, so we're not going to customize it at all. And actually, let me see, did I customize it up here at all? No, I didn't. Okay, yeah. So we're just going to go with the default parameters, and then we're going to fit it. And so what fitting does is it basically says, okay, here's the data that I've got, and here's the here are the classifications. And it learns what is in there, and it is then preparing you for your predictions. Okay, so let's go ahead and run this. Okay, and it just outputs what it found. So now it has learned that data set, and now you are ready to do the predictions. So basically we now have a model, and we're ready to do our predictions. So now that we've got our data loaded, the model has been created, now when we call the K nearest neighbor prediction, we pass into it a new set of data that has not been classified. So a new set of measurements of an iris, but we don't know which one of the three categories or classifications this iris belongs to. But when we pass in those 4 characteristics, it's now going to predict which classification it belongs to. So let's go ahead and run this. Oh, and before I go any further, you have to, I mean, this makes sense, I guess, but you have to make sure you pass in the values, the same number of values and in the correct order. In other words, the values have to have the correct meaning. So if you go back to, oops, hold on here. Go back to our values. So they have to be in the order that the data was previously loaded. So the sepal length, the sepal width, the petal length, the petal width. So that's what we got here. Sepal length, sepal width, petal length, petal width. Now we go ahead and run that. And we get a prediction of 1. So prediction of 1 tells us that it thinks it's the setosa. And that's just simply something we have to keep track of. This particular scikit-learn doesn't track that for you. You keep track of matching the numbers to the correct names. Okay, so this is sort of, in my opinion, the simplest data science project that I found that had meaning, you know, provided some meaning, and yet has quite powerful, quite frankly. And you can load a lot of data in here and make it even more accurate. But and you've got lots of different classes you can use. I didn't choose neighbors, nearest neighbors for any particular reason, but you know, that was the example that I had seen, and I'd seen a couple other examples. This one seemed pretty easy, and I think the trick really is to play around with a bunch of different classes, try to figure out which one fits your particular data. And I haven't really gotten to the point now where I understand all the ins and outs. I do know that you can specify, you know, how many neighbors you want to look for before getting classified, and you know, there's a lot of other variables in there that I think you can tweak, but I haven't gotten to doing that yet. Okay, so that's basically our first example, and I'm going to do another example, and the second example is actually going to have text in it, which presents a different kind of problem. So let's go ahead and load that up. Okay, so now we're dealing with a different problem. Oops, let's see, here we go. And in this case, we have a problem where we're simply trying to take data. In this case, we're not using the iris data set, which we had used to predict whether a new iris belongs to a particular class. In this case, we've got text. And the problem that we're simply trying to do is very simple. This is actually something I kind of made up. And I've got some tweets. Now, these are very simple tweets. These are actually not even real tweets. I just made these up just to make something very simple. It could be any kind of text. It does not even have to be a real tweet. But what I want to do is I want to classify whether or not this is a question or a statement. I might want to do that because I might want to evaluate tweets to determine if I need to respond to them. So is somebody asking me a question about my company or my product or an event that I'm at? And I need to know, do I need to respond? And questions are probably a good idea to respond to first versus, you know, statements and all that kind of stuff. So very simple example, but you know, I wanted something simple for this tutorial. So the challenge, however, is that Text analysis is very popular. Okay, it's a major application field for machine learning algorithms. However, the raw data cannot be fed directly into the algorithms because it's text, because they expect numerical features or feature vectors or values. So, and also the algorithms expect a fixed number of fields or columns, however you want to call it, to be passed in, a fixed number. Well, you can see over here in this example, although most of them have 4 words, okay, those 2, and this last one does, should you expect tweet to always have 4 words? No. So I throw in here, just have 3, okay? And that would screw up the algorithms. So you got to figure out some way to get the text to be not only turned into numeric values, but also to be turned into the same number of numeric values for every example. And that's a bit of a quandary. How do you do that? So, turns out that there is a technique that is used to do this, and you can use something called the count vectorizer to basically convert your text into a matrix of token counts. Okay, what is a token count? All right, well, this is something I learned about when I was learning big data quite a few years ago, and I was learning about map and reduce. And basically what you have is a total number of all words that, all unique words that exist in all of your tweets. So if you get rid of all the duplicates and you simply limit, take all the tweets and break it down into just words and then index them or whatever you want to do to make sure you've got unique words, and then count those unique words, that's going to be essentially your matrix for possible words in a tweet. Okay, and even though that tweet might only have 4 words, you know that those 4 words are out of a possible, let's just say, for argument's sake, 100 words. And what you need to do then is, for that tweet, you are going to have 100 fields which are mostly zeros, except for the 4 words that were actually represented by that tweet. And they will all have a 1. Or, for some reason, a word is multiple times, it would have a 2. So then what you end up with is this very large matrix of token counts, and the token is the word. That's the token represents the word. So the token is a number representing that particular word, and then a count of how many times that word appeared in that particular tweet. And now you can pass in all of these all of these rows of 100 mostly zero fields into the algorithm, and it will understand what to do. It doesn't sound easy to a human being to evaluate. That sounds like a lot of zeros and, very sparse set of data there. But the algorithms know how to handle this very quickly. So that works out very well. Let's go back over to our tutorial here. And I've already ran this before, it looks like. So hold on a second here. Let's go ahead and clear this out. I'm going to clear the output. And now I'm going to go ahead and run this first one. Again, it's simply importing pandas as PD, and then it is going to load into sklearn using the neighbors class, or the kneighbors classifiers simple train, and it's going to load in where's my cat as a value, I am ready for summer as a value, who wants dinner as a value, and where is the game? Okay, let's do that. All right. So, oops, I got an error. Why did I get an error? I must have screwed something up. I don't see it quickly here. Did I cut something out? Hold on a second. Let me go ahead and close this. All right, and let's try loading that up again. All right. Uh-oh. Well, this is no fun. Let's see. From scikit-learn. All of a sudden, this is not working, and I'm trying to figure out what I did wrong. Setting it equals is the right thing to do there. This is not all of a sudden working. Why is that? Invalid syntax. Huh. I just had this running a while ago. Why is it not working now? Very strange. Okay, well, this is no fun. I don't think it has anything to do with spaces, but let me just try that. It really shouldn't cause, nope. Let's see. Okay, well, I'm not going to get too caught up on this because it's telling me my from import. Oh, wait, hold on a second. Let's see. Yeah, it does look correct. Somehow I screwed something up. Okay, well, let me just talk through this then. So what's going to happen here is we're going to load up using, or we're going to load up this data. So it's going to go by a little bit quicker than I thought it would because I'm not going to go through all this right now. And if everything were working correctly, when we get here to vectorization, what would happen is we are now counting. This is what's happening here with the count vectorizer. This is really the big takeaway from this particular tutorial, is it is figuring out how many times where appears, how many times is appears, how many times my appears, right? And cat, etc. And it's then creating this array that has a bunch of zeros in it, but wherever there's a word in that particular tweet, it gets a 1. And I don't think there's any duplicates in here. So where's the game? Who's okay? So we have where twice, but that would be in separate tweets. So there's still going to only be a 1. So we wouldn't ever see a 2 anywhere. Okay. So we end up with a big array. And then as you get back down towards the, as we keep going down here, we actually then, it then fits the array, which means it now understands, you know, the quote-unquote vocabulary or the fields and the values. And then we can actually pull out the names. Let's see, I don't think this is going to work, but let's go ahead and try it. Okay. And what it's going to actually do is it's going to strip out any of the syntax, like question marks, or if there were any, I guess I already stripped it out there, but if there was any quotes or anything extraneous, it would strip those out so that all those words can be similar. It also gets rid of capitals, so uppercase and lowercase are basically ignored. All right, and I think at some point I'm going to get, oh, for some reason it seems to be working. All right, so then here you can see that it's pulled out all the words, and we've got cat, dinner, for, game, I'm, is, my, ready, summer, the, wants, where, who. And you can notice that where is only shows up once here, even though it's actually here multiple times. That's because we're just looking for the total number of available words. And then now we're going to go ahead and train the document term matrix. So this is actually where it creates all those individual words. And let's keep going. And here you can see them. So this is the actual printout of the document term matrix, which has essentially one of these rows for each tweet. Okay? And now you can see how the words, you can't see the actual column headers right here would be the actual word names, but you can actually see that the words have been turned into ones and zeros. Just simply a count of does that particular word. And I bet you I can pick where the word where is, because where should have 2 ones. Here it is right here. So that's the column for where. I don't think, or maybe it could be this one right here. So one of these is, one of these is where. Okay, so we keep going. And yeah, shoot. So eventually this is going to crash because of this crash up here. And it's kind of lame that I can't figure out that invalid syntax, but whatever. Just keep going. And then eventually we're going to train the whole thing. And again, you know, some of these are going to work, some of these aren't because we don't have all the data loaded up correctly. But you can see here that it's training the data. Oh, and let's see, at some point, so by the way, this is where it turns it into a, we've created a sparse matrix, and a sparse matrix basically allows you to store your data in, instead of having a 1 and a 0 for a giant matrix, instead what it does is it stores the location, the coordinates of each one of those ones, or it could be a 2. And then that's all you store, because now when you want to look up the value, you just say, does that coordinate exist? If it does, look up the value. If the coordinate does not exist, then it's a 0. And it's just a much more efficient way of storing large matrices that have mostly zeros. So, and now what we're going to do is we're going to find out whether or not we think this is a question or not. So let's see what's going on here. Oops, I didn't mean to do that. Press the wrong button here. Okay, crap. Okay, so it's not going to work because I've screwed up somewhere. But if we were to run all these, eventually what would happen is we'd get down here where it would say fit, and then we do our predict. And our prediction should give us, I think, what did I say? A question was a 1. So had I done this all correctly, let's see, where is it in here? Yeah, so I have, this is where I've actually scored all of my questions. So 1, 0, 1, 1. If you go back up to the questions, 1, 0, 1, 1. So these are the 1, 1, 1. These are questions, and this is a statement. And so because it has the word where and is, my guess is that if I had been able to done this correctly, it would have output, the answer here would have been an array with a 1. And I'll have to figure out what the heck I did up here, because that certainly looks correct to me. But there you go. So I'll clean up this notebook, make sure that it's running correctly, and then publish this again. You can find this again at on my webpage here at my GitHub account, which is dnielsen/Jupyter-Notebooks-102, and you got all the data sets right in here. And you've got the this is the second tutorial, and you've got the first tutorial right here. Now, and that's what I've got for you today. I want to thank you for bearing with me in my little error there. But once you've got your data loaded, and if you're using text, you've got it converted into numbers, then you can do quite a lot with it. So in this case, we did a little bit of machine learning, but there's all sorts of things you can do. You can do sentiment analysis. You can do all sorts of other types of predictions. And that's what I'm going to dive into next. I'm going to get ready for my future webinar where I will have all my code working, and I will also have a couple of different algorithms to compare so we can see what different results we would get with the same data set. And that's it for me. I think I'm out of time, or almost out of time anyway. I don't know. Do we have any time for questions tomorrow?
We've got 3 minutes, so I'm going to go ahead and say no. We did get some feedback from Carmen, who was following along, and said the notebook that you had available in your GitHub repo was working. So that's promising. And we'll definitely include the URL to that repo on the community site along with the recording. So if folks want to follow along and step through it, they can do that. It does, like I said, it does sound like it's working. So it's probably just a silly error somewhere.
Yep, well, I guess that happens, but
Like
frustrating.
any
Okay.
good tech demo, right? Like it always happens. But I want to thank everyone for joining us today. Again, this will be available out on our community site. That's community.trustedanalytics.org. I will try to get it up there as fast as possible, and it should be up there within about an hour. So check for that. Like I said, I will point you to Dave's GitHub repo here that he's working with in case it's too challenging for you to find on your own, but it will be paired with the recording, so you'll be able to find it there. Thanks so much for joining us. Thanks for helping us close out 2016 and our data science series of webinars. We hope to see you next year. Thanks.